It is the fourth brightest natural object after the Sun, Moon, and Venus, and also the fifth planet from the Sun. Jupiter is a hot, puffy gas giant with enormous storms, strong winds, and extremely high temperatures and pressures. This planet is also widely known for its gigantic size. It is 11 times larger than Earth. Want to know something else that's large? It is the James Webb Telescope, JWST or Webb. JWST is not only the largest but also the most potent space telescope in the world, and this witty space invention is already exceeding our expectations. It recently found signs of clouds on an exoplanet on the hot Jupiter, which was previously believed to have crystal clear skies. What a startling discovery! The James Webb Space Telescope also provided graphic images to give a good view of the planet. We will be able to identify some well-known aspects of the enormous planet in our solar system in these pictures taken by Webb using infrared light. In this video, we would be discussing James Webb Space Telescope's mind-boggling discovery of Jupiter. Let's take a quick look. Jupiter, also called the Lord of the Planets, is a stormy enigma covered in vibrant clouds and named after the type of gods in Roman mythology. Its atmosphere, which is primarily formed of hydrogen and helium, is also similar to that of the Sun. At the center of the planet, a fuzzy or partially dissolved core is encased in a fluid metallic hydrogen layer rich in helium. According to NASA, Jupiter is more than twice as massive as all the other planets put together. More than 1,300 Earths might fit within Jupiter's enormous bulk. The size of Earth would be equivalent to a grape if Jupiter were the size of a basketball. Probably the first planet to originate in the solar system, Jupiter is composed of gases that were left over after the Sun was created. According to NASA, the planet would have grown to be a star in its own right if it had been around 80 times more massive during its formation. Recently, new photographs of the planet were taken by NASA's James Webb Space Telescope. JWST not only captured beautiful photographs, but also did an insightful analysis of light from far-off objects. Webb's view of Jupiter will provide researchers with considerably more information about Jupiter's interior. Planetary astronomer Imke de Potter, who is also a professor emerita at the University of California, Berkeley, together with Thierry Fauchet, a professor at the Paris Observatory, oversaw the Jupiter observations as part of a global partnership for Webb's early release science program. The Webb mission itself is a collaborative effort between NASA, the Canadian Space Agency, and the European Space Agency, Canadian Space Agency. The observatory's near-infrared camera, NIRCam, which has 3 specialized infrared filters that highlight the features of the planet, produced the 2 photos. The light was mapped onto the visible spectrum because infrared light cannot be seen by the human eye. The shortest wavelengths were typically represented as more blue, whereas the longest wavelengths tend to appear redder. De Potter remarked that they hadn't expected James Webb's discovery to be this good. The fact that we can see the intricacies of Jupiter together with its rings, tiny satellites, and even galaxies in a single shot is very amazing. Judy Schmidt, a citizen scientist, worked with scientists to convert Webb's data into photos. The photographs also vividly depict Jupiter's surrounding auroras, enormous storms, moons, and rings in remarkable clarity. According to researchers, to make the characteristics stand out, the infrared images were colored artificially. According to NASA, auroras could be seen extending to great heights above both the northern and southern poles of Jupiter. In the standalone view of the planet, this was produced from a composite of many telescope photographs. Auroras are light displays in the planet's atmosphere brought on by interaction with solar wind particles. The Great Red Spot, a legendary storm that is so large it could completely engulf our beloved planet, was portrayed to be white in the image. This was a result of how much sunshine it reflected. According to Heidi Hamel, Webb's multidisciplinary scientist for solar system observations and vice president for science at Aura, this brightness suggests high altitude. Hence, the Great Red Spot and the equatorial region both have high-altitude hazes. The countless dazzling white spots and streaks are the very tall cloud tops of condensed convective storms. Dark ribbons north of the equatorial area, however, are mostly cloudless. Blues, browns, and cream are used to depict the planet's wavy horizontal stripes. Jupiter's north and south poles are illuminated by electric blue auras. What is it about these auras? The auras emit a bright white radiance. Rings on the planet provide a faint white glow toward its equator. Additionally, Webb was able to capture parts of Jupiter's rings, which are 1,000,000 times fainter than the planet, and 2 very small moons. The Jupiter photographs show the complete range of what Webb can see, from the weakest, most distant visible galaxies to planets in our cosmic backyard that you can see with the naked eye from your actual backyard. The F212N filter used by NIRCam to see light with a wavelength of 2.12 microns, or roughly the size of a common bacteria, was used to focus on Jupiter for over 11 minutes to produce the new image. Since researchers may utilize the filter's data to analyze molten hydrogen, it has won a seat in the observatory. To learn more about the largest planet in our solar system, researchers have already started examining Webb's data, but it might take a while. Why? Well, the information from telescopes like Webb doesn't come in a tidy bundle to Earth. Instead, it includes details regarding the intensity of the light detected by Webb's detectors. The Space Telescope Science Institute, Webb's mission, and Space Operations Center receives this data as raw data. The data is calibrated and sent to Mikulski Archive for Space Telescopes for distribution after being processed. These fresh pictures of Jupiter were analyzed by veteran citizen scientist Judy Smith of Modesto, California. What's more, she's a self-made genius. Schmidt lacks any formal training in astronomy, but 10 years ago she discovered her unquenchable enthusiasm for image processing through an ESA contest. The public was encouraged to sift through Hubble data for new gems as part of the Hubble's Hidden Treasures contest. Out of almost 3,000 entries, Schmidt's photograph of a nascent star won 3rd place. She's been working on Hubble and other telescope data as a hobby since the ESA competition. She explained that something about it simply stuck with me ever since, and she can't help it or stop it. Every single day, she spends hours upon hours without end on telescope data. That was how she has since been able to process photographs of nebulae, globular clusters, star nurseries, and other more amazing cosmic things. Her love for astronomy images is unrivaled. While we await the result of the analysis, there are a few other things that JWST's recent revelation has helped scientists to find out. For instance, scientists claim that the telescope has detected evidence of sulfur dioxide in addition to carbon dioxide, water, and other molecules as revealed in a series of recent scientific studies released online. The gas must have been created by a series of chemical reactions in the atmosphere of Jupiter. Planetary atmospheres include a significant amount of reactions brought on by light. For instance, sunlight creates ozone in the Earth's atmosphere, which prevents dangerous radiation from penetrating the surface of the planet. However, no planet's atmosphere outside of our solar system has ever had this kind of chemistry before. In addition to detecting a rare kind of chemistry in the atmosphere, astronomers found evidence of a patchy, dispersed cloud cover on the planet. It's always amazing to discover something new about these planets because it paints a better mental image of what the planet looks like. From what we've gathered in this video, the Next Generation Space Observatory, JWST, has set great expectations for what it can reveal to scientists about the Jovian system. Researchers intend to examine the layers, composition, temperatures, winds, and auroral activity of the world's clouds. To better comprehend the origins and future evolution of Jupiter's ring system, astronomers also seek to better grasp its structure.